Hola and what's up to you all, matriculants? Welcome to it. This is Learn Extra with me, AB. It is a lovely Monday at Triple M Day. Mine it is Maths Monday. I hope you had a great day at school, and I know that some of you were writing, so I can't wait to hear from you guys. How did you guys write? I'm sure you guys did well because I trust you guys. I believe in you guys. Well, today we do have Wilson again. Say, how are you?
I'm doing well on your album.
I'm good. It's good to be with you again today.
Yeah, great. Fantastic day, guys. We have matric, and today I'm doing revision of functions, guys. And algebra, grade 11s, you can still stay there. I mean, the functions that we do, actually in grade 11, you do in matric. And the algebra, which is the same kind of a thing, I'll be looking at an example on nature of roots, exponents, and those functions, guys, okay? Yeah, bro.
Yeah. Don't give away everything. You guys need to stay tuned. But, well, you can also chat with me. Let's communicate and chat via facebook.com/learnextra. Like that page, share that page. At the moment, we have about 79,500 and something likes. So, guys, let's get to 100 by the end of this year or by the end of this term because I have trust in you guys. Don't panic because during this time, I know that you guys tend to panic a lot on the page, but don't. We're here to help you, and you guys should help one another on the page. That's our spirit. On Twitter, follow us at LearnExtra. And remember, we do have your notes links on Facebook, which is the viewing option and the downloading option. And lastly, we have the test yourself link, whereby if you answer those questions correctly, you stand a chance of winning this awesome Casio calculator. You need this buddy during your exam. It's the best buddy to have ever. It has about 254 functions as we are doing functions today. So guys, maybe Browson will share some of his tips later on using this calculator, some of the tricks that you guys can use as matriculates or shortcuts on using this calculator. But lastly, we also have the Nokia mobile mathematics app, whereby if you log on it, you can challenge yourself and challenge other mindsters. It's all about mathematics. You can revise algebra and functions, what we're doing today, and let's see how well do you understand them. If you're struggling, we are still here to help you. Your code is simple, I2IK. I2IK. So guys, without any further ado, let's get to the lesson.
Okay, thank you, Abram. Okay, guys, welcome out there. I hope you're ready. You have a pen in front of you. You want to try to do the problems. I mean, the nature of mathematics and how we study maths. You don't look at the problem. And there's nothing wrong if you do maths and you don't understand the problem straight away. That's the nature of maths. Okay, so you try to do it again. That's the essence of mathematics in a way. You try to do it again till you understand it. You don't get worried if you don't understand the problem. Okay, and matriculants are there. You still have time. This is June. You still have lots and lots of times. Grade 11s are there. Pre-matrics, you're also welcome to view the show. Okay, great. Let's see, guys, what I have. We have revision of functions in algebra. So I'll be revising the functions and algebra. Okay, great. Let's see what I have. There I have a challenge question for you guys. Let's see what I have. You have a function, a graph, which is y equals to ax squared plus bx plus c, which is the parabola, which is given. Which of the following statement is true? So let's see there. There's the graph. Okay. Which of the following statement is true? Where b squared minus 4ac equals to 0, is c bigger than 0, is a bigger than 0, or is b squared minus 4ac equals to 0, c bigger than 0, and so on, guys. I hope you're going to try the problem, guys. Post the answer on Facebook. Which of the following makes this true? Okay, post the answer on Facebook, guys. Okay, great. I hope you try this challenge question, guys. Fantastic. Let's see what we have now. Okay. There's the summary there. By now, you know the standard form of a parabolic function. There's a standard form of a parabolic function. ax squared plus bx plus c. How do you find the y-intercept? You make x 0. That's how you find the x-intercept. You make x 0, then you get your y-intercept, which is the c value in this case. For any graph, hyperbola, exponential, straight line, the same principle holds. Then the x-intercept, you make y 0. Remember, if you're struggling to factorize and so on, you can use your quadratic formula. So to get the x-intercept, you make the y 0. Then you solve the x value. Okay, good. Remember, the axis of symmetry. What is the axis of symmetry? Because the parabola is symmetric this way. What is the x value that makes that parabola symmetric? So that's the axis of symmetry, which is that, which is minus b divided by 2a. That is the equation of the axis of symmetry. To get the turning point is the axis of symmetry. Then this value, you take the value of the axis of symmetry, which is x, you substitute that into the original function to get the corresponding y value, okay, to get your turning point, if it's in that form. Great. Another way for a parabola, if it's in that form, you notice anything, is that the completing of the square form. So the turning point in this case is minus p, which I get from there, and q. There's your turning point. Okay. Then horizontal shift. If p is bigger than 0, okay, there's p. Then this is a horizontal shift. P also, this is horizontal to the left, and when p is less than 0, it's horizontal to the right. And this moves the graphs up and down. Okay, if I add q, if I make minus, then the graph moves down. If I add, then my functions moves up. Okay, those are for p and q. Okay, let's look at the hyperbola, this side. Hyperbola. This is a standard form for the hyperbola. K over x plus p plus the q there. Same principle holds. P is the horizontal shift to the left. And p horizontal. If p is less than 0, it's horizontal shift to the right. And so on with the q. I can move the graph up and down with the value of q. Okay, guys? And what about the asymptote? If x is negative q, then I get my negative p, or y is q. Those are your vertical and horizontal asymptotes, guys. Okay, great. Let's look at exponential. What about exponential function? This is the standard form. Same thing, if p, this is the horizontal, shift to the left, okay? Okay, and p there is horizontal shift to the right, okay? And your asymptote, which is y is equals to p, is your asymptote. If you check your hyperbola, you have two asymptotes, the horizontal and the vertical. What about exponential? You just have what? One horizontal asymptote. Do you have asymptote in parabola? No. I just have the axis of symmetry. Okay, great, fantastic. Now, let's look at another concept, exponential. Exponential laws. This exponential law, guys, remember, they only work if you have multiplication everywhere, then I can apply all this exponential law, guys. Okay? Okay? Same base, add exponents, same base. If I divide exponents, I minus exponents. And this is power to power. The exponents times that, and this times that, and the lastly, law of exponents, guys. Okay, just to remind you this, I think by now you can do this laws of exponents. Good. The nature of roots. I love this section. This is one of my favorite section in maths. So nature of roots, before you do your nature of roots, your equation must be in that form. And remember that delta is given by b squared minus 4ac. Okay, there's your delta. If I have ax squared plus bx plus c in the standard form, then delta, where do I get that delta? If we check the square root, underneath the square root from the quadratic formula, it actually gives you delta, which is b squared minus 4ac. Okay, great. Now, let's check what we have there. If the roots are real, delta must be bigger or equal to 0 for real roots. Equal roots delta is equals to 0. Rational rules is that delta is a perfect square, like 16, 25. X squared is a perfect square. The roots are rational. Irrational roots, delta is non-perfect square. It's not equals to a perfect square. Okay, like 5. 5 is not a perfect square. Therefore, the roots of that would be irrational. And non-real or imaginary roots, delta is less than 0, guys. Okay, that's the part of nature of roots. Okay, great. So I went through the summary. Okay, so I think we're going to go through the break. Then when we come back, straight we hit the first problem. Okay, Amra.
Well said. Well, on that note, here's a quote from Nomfundo Cheryl Shezi. She says, it's not about what you know, but it is all about how you use what you know. It's all about that mindset, and you know.
Hey, that's nice. Huh?
That's a very nice one.
Yeah, great.
It's all about how you use what you know. So guys, use whatever you know to your best advantage and use it correctly. We'll see you after the break. Welcome back, matriculants. Now, exciting news. I'm about to announce last week's winner on the Casio calculator, and I'll do the drum roll, and then you announce the winner.
I will.
Let me try and add some sound effects.
Ndijeni Poza. Is that correct?
Podza.
Podza. Ndijeni,
Okay,
yeah.
it's Podzo.
Okay.
Yeah, it's Podzo.
Okay, well done, Ndijeni.
Congratulations. Well, to be like Podzo, all you need to do is to do the test yourself questions, answer them correctly, get most of them or all of them correctly. I've been having some complaints from some people saying I've been entering but not winning. It's either one, yes, you did get the answers correctly, but someone got them correctly also before you.
Yeah.
So it's also about the time. So if you got your answers and sent them at 6 and someone sent them at like few seconds before 6, then they get to be the winner. So time counts, 2 mindsetters. So don't waste any further more time. Get to the challenge question right now and the test yourself questions.
Great, fantastic, good. Let's see. First question. Let's see what I have here. It's very important, guys, again, to read the whole problem. You know, if you don't read, you might miss some small thing there. So let's see what I have here. In the sketch alongside, given us a standard form, likely there's a minus x, a over x minus p plus q. C is the point of intersection of the axis of symmetry. C is the point of intersection of axis of symmetry. There's C there. I can see my C there. F. So we have symmetry of F. We have y equals to x plus 2. Y equals to x plus 2. The gradient is positive, so it's actually this straight line. Y equals to minus x minus 4. It's that straight line. Then they intersect at C. F passes through the point 1, 0. So this point passes on our hyperbola. The first question, find the coordinates of C. Where are the coordinates of C? There's the coordinates of C, guys. And is where actually the two straight lines intersect like this. How do I find the coordinate of intersection of the two graphs? You just what? You just make the two graphs equal. Then you solve them simultaneously. Let's see what can I do. So I have two straight lines. I can make them equal, which is y. Okay, in this case, let me just make them y is x plus 2, which is the first straight line, and the second straight line is y equals to minus x minus 4. So to determine the coordinates of C, what I do, I make the two lines equal, which is x plus 2 is equals to minus x minus 4. Then I move the x the other side, I get 2x, because if I move this side, I get 2x. Then I move this the other side, I get negative 6. Divide by 2, divide by 2, you get the x axis, negative 3. And we get x is negative 3. Check yourself. Is x negative there? Let's see. Is this true? That's possible, yes. Here, this x-axis, all x's are negative there. So this, if you see, you get a positive answer, then you made a mistake or something, because this must be negative everywhere. Okay, now, I have the x value there. How do I get the y value? I take this, sub into any straight line. I can sub into the straight line there, then I get y. What is x? The x value there is minus 3 plus 2, therefore y is negative 1. Okay, then I'm not done. The question was, find the coordinates, guys. The coordinate is an ordered pair. So I cannot find x and y, then stop and say, this is the coordinates of C. No, that's not correct. The coordinate is an ordered pair of x and y. So I have to write the coordinates of C in this case. So therefore, the coordinates of C is x is minus 3, y is negative 1. That is the coordinate. So if you write minus 1, minus 3, you won't get all your marks. So you have to write the coordinate, which is minus 3, minus 1. That's the first question, done. Second question is find, so the coordinates of C, let me erase this and see, is minus 3. The coordinates of C is minus 3, minus 1. So the second question is find the equation of F. What is the equation of F? This is the hyperbola. Can you see? The equation of F is hyperbola. Let me write the standard form. There's the standard form. So, find the equation of F is the hyperbola, which is y equals to a x minus p plus q. Okay, so I have to find a, p, and q. I have to find the value of a and q. Let me see if I can read this from the graph. So, if you check here, the coordinates of C, I have minus 3, minus 1. So that is the coordinates of C at that point. What it means, this line is x minus 3. And what can you notice? And what about this line? It's y is minus 1. Those two are actually my asymptote. The value of p and q. I don't know if you can see that. So y there and x there, that give me the value of p and q, my asymptote. Let me reverse this. So p and q, if I reverse my p and q, I get that C, I get that y equals to a x plus 3, which is the x, and minus 1, which is the q there. This isn't complete also. I substituted my p and q, but I still have to find the value of a. How do I find the value of a? Remember, if I have a point that lies on the graph, I can take that point and substitute the point into the standard form. For any graph, it holds, the statement holds. So to find the value of a, find the point that lies on the graph and substitute the point into the standard form. Let's see if we have any point that lies on the graph. Okay, so there is the point that lies on the graph, 1, 0. It lies on the hyperbola, 1, 0. So I have to sub 1, 1, 0, not minus 1. It's 1, 0. Then if I sub 1, 0, what is x? What is y? Y is 0. What about x? A over 1 plus 3 minus 1. Then I have to solve the value of a. So this is 0, a over 4 minus 1. Then I can do this. I can multiply by 4. 4 is my LCD. If I times this by 4, I get 0. Then I get a, negative 4. Therefore, a is equals to 4. But remember the question was find the equation. So what I have to do, I have to write my equation down, which is y equals to 4 over x plus 3 minus 1. This is the equation we have to determine. Okay, guys, I hope it makes sense. Take a point that lies in the graph and substitute that. Remember, you can't take any point on a Cartesian plane and substitute in the standard form unless that point lies on the graph. It's on the graph. Then you can substitute the point, guys. Fantastic. I hope you're enjoying maths, guys. Okay, fantastic. Good. Let's look at the next question. What do we have here? Beautiful. The next question. Okay. The graph of f is defined by this. This f at x is defined by x squared. Identify the graph that represent the following transformations. There's f, let's see f, there's f, there. Can you see the f? Now we have to identify the graphs defined by the following transformation. First transformation, second transformation, and the third transformation. Now check this. What is x inside? F of x minus 2. It means that you take the graph, you move it 2 units to the right. I mean, you might think because no, minus, I'm thinking left. It's actually 2 units to the right. Let's check a graph that is transformed 2 units to the right. 2 units to the right. 2 units to the right. This is the graph because 2 units to the right there. Can you see? Think about the turning point is 0. Then if I transform 2 units to the right, I will get there. So this is the graph. I think this is G. This graph G. So this is G. What about f at x plus 2? F at x plus 2. The transformation where you move f at x 2 units up. So which graph moved 2 units up? Which one moved 2 units up? It's actually this one. Can you see the graph? This one moved 2 units up, which is P in this case. P. So P is the graph. Okay, what about when you multiply f at x by negative? Where's the graph? If you multiply by negative, you're actually reflecting it into the x-axis. So let's see a graph reflected into the x-axis. It's actually 2, this and this. They're both reflected into the x-axis. Will it be S or R? Let's see. It can't be this one because the f at x is from the origin, so it should be this, which is R. So for this one, we have R. Okay, guys, good. Those transformations, they're really good. Learn the transformation, practice and practice and practice, guys. I hope this makes sense. Good. Try next question. Let's see what I have here. Okay, next question. Okay, read again. We're given f at x, which is x squared, 6x plus 14, and g at x, which is minus 3x, minus 4, which is the parabola and the straight line. We're given that AB is 54 units. Where's AB? AB, this distance is 54 units. So we have that distance is 54 units. The question is, calculate OC. Where is OC? The distance from origin to C. How can I do this? How can I really do this, guys? Are you processing? Are you thinking? I have a parabola there, a straight line, and I have a distance between the two graphs. I have to calculate the distance from O to C. Let's see. Can you think of any formulation? Let's see. The distance from A to B, AB, can you see the AB, which is the distance, that gap is actually This is f at x, which is our parabola, and this is our g at x, which is a straight line. So the distance between two graphs, AB, is f at x, which is the top graph, minus g at x, which is the bottom graph. Okay, g at x, which is the bottom graph there. G at x. So what is f at x? There's my f at x. X squared 6x plus 14, which is x squared 6x plus 14 minus, very important, in bracket there, because we're minusing the whole thing, which is my parabola, which is the straight line, minus 3x minus 4, minus 3x minus 4. It's very important that you have this minus, because this is, you're minusing the whole of g at x. Okay, and let's do algebra here. But what is AB? Let's look at A. What is AB? AB is given, which is 54. So now I can say this is 54 there. Then let me do some algebra. 554. This is x squared, 6x, 14, and 3x. I distribute the minus, plus 4x. Then I get 54. This is x squared. If I add the 2, I get 9x. This 2, I get that this is 18. Then I get an equation. Can you see that? I get an equation. Let me move everything one side. 0, x squared, 9x, plus 18 minus 54. Therefore, this is 0, x squared, 9x, plus, what is 18 minus 54? 18 minus 54. 18 minus, minus 20 there. If you minus 20, you get 34. So it's actually minus 36. Okay. Then factorize the 0. If you can't factorize this, use your quadratic formulas. X. I want the factors of 36 to give me 9, which is 12 and 3. This is plus, and this is minus. Therefore, x is negative 12, or x is equals to 3. Now, let's interpret this. So, if x is minus 12, x is 3. So, actually, the distance from there to there, if you get the coordinates for that, is minus 3, 0. This minus 12 actually is somewhere there. It will give you another point between the two graphs. The minus 12 will be somewhere there, minus 12. So the distance from O to C is 3 units. So OC is equal to 3 units. Okay, guys? I hope it makes sense. I mean, I have two graphs, the parabola, the straight line, then the distance between the two graphs was 54. Then calculate the distance from there to there. What do? It's a top graph minus the bottom graph equal to 54. Then I solve x. If I solve x, I get negative 12 and 3. But I'm looking into the where x is positive, so that should be 3. Okay? And that's minus 12, guys. Okay? So, which is the distance in between. This is actually positive 3, because I get positive 3, guys. Okay, the distance is 3. Okay, I think we'll take a break and we'll come back and we'll look at the challenge question, Abraham. What do you think?
Awesome. Let's do that. And in the meantime, guys, I can see your questions. You guys are on fire. That's what we want. After the break, we'll be answering your questions. And remember, the challenge question is waiting for you guys. I like one thing about some of the people that are answering the challenge question, Wilson. You know what they say?
Yeah?
They say, my answer Okay, well, someone said that. My answer is A, and I'm 100% sure.
Great, that's fantastic. That's confidence.
That's great confidence right there. Well, guys, we'll see you after the break.
Great, fantastic, guys.
Welcome back, Mindsetters. Because I'm Mr. Nice Guy, I just shared a link with you guys, which is a very, very helpful link. It is a link to the exemplars, 2014 grade 12 exemplars. So, guys, do check them out. And here's a great comment for you, Mr. Wilson.
Yeah.
This is from one of your students.
Who's that?
It's Kev.
Kevin, Canada. Yeah,
yes,
great.
he says, "Hi, Mr. Wilson, it's Kev from your class. Great lesson. I'm really enjoying it. This is beautiful mathematics." Indeed.
Great, Kevin. I hope you're doing well. They keep working hard, Kevin. I know you can do it, but okay.
And
okay.
no extra free marks for you,
Great, no,
Kev,
no,
just
no
because you
free.
send a shout out. No, you gotta work for them. But otherwise, all the best to you and all other Mindsetters. For now, let's get to the challenge question.
Okay, great, guys. I don't know, Abram, do you have answers for the challenge question? Do you have any?
I have
What-
so many
Let's
answers.
see, what do you have? What do you have? What do you have? What is...
Okay,
yeah?
I've got B.
We got B.
I've got B. I've got A, 100% sure.
Wow, who's that 100% sure?
It's
Hey,
Khonte Sibashe.
hey, Khonse. Hey, let's see.
Yeah, hey, we'll see.
Yeah?
Others, most of them C, C,
C.
C.
Yeah?
So many C's and B's.
Yeah?
And so many A's also.
So many A's.
Yeah.
Okay, let's see, guys. Let's try. There's the graph. Which of the following statement is true for this graph? What is actually this? What is b squared minus 4ac? This is actually a discriminant. If the discriminant is equal to 0, what does it mean? If delta is equal to 0 from the nature roots, therefore the roots are equal. What do we mean when we say the roots are equal? It implies that it's something like when I solve x, I'll have something like this, x squared 2x plus 1. So if you factorize this, if this is equal to 0, if you factorize, you have x plus 1, x plus 1, then you get that x is minus 1. Or also, x is minus 1. Can you see that? You get the same thing. Oh, what did I do? Can you check? Okay. Let's see what I do. Okay. Sorry. So you get that x is minus 1 also. Another x is minus 1. So you get two equal roots. Can you see? You get two equal roots. So your parabola won't have x-intercept there and x-intercept, which is two different axes. They'll actually have one x-axis. The roots are equal. We start there. So this is the delta. When delta is equal to 0. So it's either this or this, because this can be, this can be. Because if delta is bigger than 0, we'll have two real roots, because delta is bigger than 0. Okay. Now, it passed this. So it's A or B so far. It's A or B. Let's see. So between A or B, based on this, because these two can be, Abram. So A and B pass. Let's look at the
Let's
next
just
one.
take A, B here.
Okay, AB. Okay. The next one, C bigger than 0. Remember, what is your C? Your C is your y-intercept. Is C bigger than 0? Yes. It's bigger than 0 there. So it's still AB. Still AB. But now, the last one. A bigger than 0, A less than 0. What does A do? Remember, if A is positive, you have a smiley face of a parabola. A negative, something like this. So A is positive. Then our final answer is A in this case. And well done if you managed to get the answer there. A is our correct answer. Okay, beautiful. Great. Okay.
Yeah, and I'm sure Khonte is very much excited because maybe he's probably saying, I told you guys. So well done,
Well
Khonte.
done to Khonse. Your 100 show. Can I take some few questions, Abram?
Yes, let's get to
Yeah.
Mindsetters questions.
Yeah. Let me, Okay.
Okay, let me take some comments also. This guy is a great teacher. I wish he was my teacher too. That's from Kagiso.
Kagisha, I'm teaching you, I'm touching wherever you are. You know, mathematics is universal. Wherever you are, we're touching you as mindsetters. You're going to do well. I'm telling you that. Okay, great
Awesome.
concept.
Yeah,
Great.
nice comment.
Yeah.
Nice head, Abram. And good teaching from Mr. Sokana. I'll give it to you. Let me take some of the questions from you guys.
Great.
All right, the first one is from Hlengi Wendlovu. Please help, what do we have to do when we are told to restrict the domain of an inverse?
Okay, it's actually, what can you, let me put it properly. How can I restrict the domain of the inverse to make it a function? Let's take this. I'm going to do it here. Let me take a parabola. There's y equals to x squared. Is this a function? How do you test this is a function? Use what? Your vertical line test. If I use my vertical line test, I cut the graph at one point. Therefore, there is a function. For example, if I take something like this, is this a function? No, check. If I use my vertical line test, I cut this at 2 points. Okay, for this to be a function, there must exist one corresponding y value for every x. So this is not a function, this is a function. Now, what is the inverse of this? The inverse for this, let me draw it somewhere here. The inverse for this is this. There's the inverse. I still have y and x. Is this inverse a function? No. Why no? Because if I draw a line, this is this. So if I draw a line, I cut this at 2 points. Therefore, it's not a function. But what can I do to the domain to make this a function? It's either delete this. Can you see? If I delete this, I just have a line like this. Therefore, this is a function because I cut this at 1 point only if I draw my vertical line test. Or also, because if I have this, I can also, or maybe, I don't want to delete that, I can delete that. Even this, now, this is a function. Why this is a function? Because I cut this at 1 point. Then how can I restrict the domain to make this a function? Let's go back and look at this parabola. If I look at this parabola, to restrict this to make it a domain, it's either if x is bigger or equals to 0, and I'll write this down, erase this. So to restrict this parabola to make it a function, I can do this. I can say if x is bigger or equals to 0, or if x is less or equals to 0, then this is how can I restrict that parabola to make it a function, because the inverse is this way. I can delete this or delete this. Okay, guys, great, fantastic. Do you have another question?
Yes, I have another one.
Okay.
This one is from Kwandi Swazondo. She says, why do you subtract the straight line from the parabola?
Why do I subtract the straight line from the parabola?
Yes.
Good question. Okay, let's check the problem. Should be this problem. Why do I subtract? It's actually not the straight line. Why do I subtract the parabola from the straight line? Okay, let's say this point. Okay, this point, if I have to find the distance, guys, the distance between the two graphs, and I have the y value there and the y value there, I'll use the y value because I'm finding the distance there. Then you will say that y value minus that y value. And remember, the y value at that point is represented by that parabola, and the y value at that point is represented by the straight line. That's why I say the top graph minus the bottom graph is the y value of that minus that y value to get this distance. Okay, great. Do you have another question?
I think this one is just what you have done from Sianda, saying, could you please repeat that question where we had to calculate the length of OC between the parabola and straight line?
Okay, this is what the question. So top graph which is the parabola. Which one is the top? Here, it's the parabola. Which one is the bottom? Straight line. Top graph minus bottom graph, and the distance between them is 54. You make it equals to 54, then if you solve x, you get x is negative 12 or x is 3, and therefore x is 3. Then if you check, this must be positive 3. Therefore, the distance is 3 units between the two graphs. Okay, good.
Okay,
Great.
we can move on.
Fantastic. Guys, we have more questions. I think I'm going to skip this one. And we have a third. I'm going to skip. If I get time, I'll come back to this. I like inequalities, guys. Okay, let's look at this inequality. For which values of x will the expression be real? For which values of x will this expression be real? What do you think? If I have a square root of something, how can I make that to be real? This will be real. Think about the square root of minus 4. What is the square root of minus 4? If you put that in a calculator, you get error. It's not real. It's actually a complex number. It's not non-real. But how can I make this real? I can make this real if x plus 1 over x minus 4 is bigger or equals to 0. So why bigger or equals to 0? For this to be real, anything inside the square root must be bigger or equal to 0 to make it real. Then I can solve this inequality now. Then how do I solve this? What I do, there are lots of ways to do this, the table method, the graphs. I like doing this because remember, you cannot multiply by this because we don't know the value of this is positive or whether this is positive or negative. But I can multiply by x minus 4 squared both sides. X minus 4 squared both sides. Why do I do that? Remember, inequality, if you multiply by a negative number, you change the sign. We don't know whether x minus 4 is negative or positive. To be safe, I multiply by a square number, and that won't affect my inequality. Then this is 0. Okay, this is 0 because 0 times anything that is 0. So I'll have bigger 0 there, and this will cancel the whole thing there, and then I have x minus 4 x plus 1. And if you check this, if I come here, then I write critical values. I write critical values, very important. X is 4 and x is negative 1. This is not solution. My critical values, I'm going to use this to test where's my solution. Then what I do, I draw a number line, I put minus 4 there, I put 4 there. Then I take any value, I want to test this. I take any value, let me take 0. Where's 0? 0 is in between there. If I take 0, substitute it back into the original. If I make x 0, if you make x 0, this is 0, you get negative 4. You get negative 4, you make this 0, you get 1, and is this bigger or equals to 0? So you get minus 4 is bigger or equals to 0. I just substitute 0 there, then I get minus 4 bigger. Is this true? Is that statement true? Therefore, this statement is not true. This statement, any number between minus 1 and 4, it won't work. Okay, try this at home. Take a number after 5. If you take a number after 5, substitute it there, you'll find that number is actually bigger than 0. It will work this side. If you take a number less than minus 1, substitute the number there, you get that the number is actually bigger than 0, which actually works. Then now I write my solution that x is less or equals to negative 1, or x is bigger or equals to 4. Let's check back. This isn't correct. There's something I have to do there. Let's look back. Actually, x, if I restrict it, you have to restrict. Can x be 4? If I was to check that, x can't be 4 because you can't divide by 0. So x cannot be 4. X can't be 4 because if x is 4, the expression is undefined. Then what I can do from that, I have to delete this. So x is only bigger than 4. Another way of doing this, drawing the parabola with this x-intercept, and that x-intercept, and you check where is the parabola positive. It's positive this arm and that arm, where x is negative, when x is smaller than 1 or x is bigger than 4. That's another way of doing this. Okay, guys, let me look at another problem. Let me jump into this. Okay, next one. Love this one. Nature of roots. Determine the value of k if the equation, that equation, has equal roots. What do you know about equal roots? Equal roots. Delta is equal to 0. So let me simplify the expression. My LCD is x. I get x squared. If I simplify this, I get x squared. I times that by x also. I get 2x. I get 2xk. Then I get 9 plus kx squared. Okay, move everything one side. I get x squared minus kx squared, 2x, okay, which is plus 2x plus 2xk minus 9 equals to 0, because I have to write this in a standard form. B squared minus 4ac into 8x squared plus bx plus c in the standard form. Then if I have this, if I take it a common factor x squared there, I get that 1 minus k is equals to x squared. Take a common factor x there, we get that this is actually 2 plus 2k x minus 9. This is equals to 0. Therefore, this is in the form ax squared plus bx plus c. What? This is my a value, b value, c value. Then I can what? Write my discriminant, which is what? Delta is b squared. What is b squared? That is b squared, which is 2 plus 2k squared minus 4. What is the a value? A value is 1 minus k, and the c value is minus 9. Then what do you do there? You say delta. You can simplify this. If I simplify this, I get 4. Okay, if I square that, I get 8k plus 4k squared. And from there, what I get, if I times, I can times 9 inside if I want. First, minus 4 inside. Then I get minus 9 plus 9k. Okay. Then delta, which is 4, 8k, 4k squared. What is now 4 times 9? 9 times 2 is 18. 18 plus 18, I get 36. That's correct? 36.
Yes.
Then I get plus 36. Then if I times that, I get minus 36k. Then I add like terms there. Then I get delta. I get my delta, which is still, I have 4. If I add this and this, I get minus 28k. Minus 28k, I should have actually added this, which is 4 and 36, which is 40. So I've added this together. Then what about 4k squared? Now, I have my discriminant. For which value of k will this be equal? I make the discriminant equal to 0. So there's the discriminant. I say 40 minus 28k plus 4k squared equals to 0. So I solve for k. Okay, so you factorize this and you solve the value of k. Then if you can't factorize this, what you can do, divide this by what? You can use a quadratic formula to solve this problem. Okay, guys, okay. I think we're running out of time. Or should I complete the problem? They can.
Complete it.
Okay. So let me rearrange this properly. Divide, so this is 4k squared minus, let me cancel this. If I have 4k squared minus 28k plus 40, I'm just writing this in the standard form, plus 40, divide this by 4, I have k squared, 28 divided by 4, isn't that 28 divided by 4, divided by 2, 14, 7, no?
Divide by 2 or 4.
I'm my arithmetic. I'm dividing 28 by 4. So 28 divided by 4
7.
is 7.
Yeah.
Thank you. So you have minus 7k. You divide that by 4. Also, you get 10. Then you can factorize this. The factors of this is actually 5 and 2, which is minus and a minus. Then if you solve k, you get that k is equals to 2 or k is equals to 5. Okay, great, guys. Okay, we can finish the problem. The final answer, k is 2 and k 5. Great, fantastic. Over to you, Abram.
Thank you so much, sir. It's been a great lesson, and I hope you guys have also enjoyed it. I'm leaving you with a quote from Francis Chen, which says, "Our greatest failure shouldn't be just about failing." That's our fear. Shouldn't be about failing, but it's succeeding on things that really don't matter. So guys, don't be scared of things that do not matter. Rather care about what matters most. And we're here to help you whenever you're struggling. We have our help desks that is there to help you guys. So the link is on Facebook. We love you. And tonight, we just want to leave you in peace. All the best to everyone that is writing tomorrow.